Hey mechatronics students. In this video we're going to be talking about tool frames. This is a really interesting thing. I'm demonstrating the rotation of the robot, jogging it in world mode about the minor axes. And you can see as I'm doing this, the end of the tooling doesn't change when I rotate about the minor axes in space. This makes it a lot easier for the robot to pick things up and to jog the robot around and get to certain spots, and it kind of compensates for the end of arm tooling. EOAT is the acronym that's used for this. So let's talk a little bit more about these details. So in tool frames you have the ability to program in an offset, and basically you've got, say this is your fixed point that you want to get to. And here's the robot arm, and as you're jogging it around, it would be sort of a pain if we had to compensate for this and say we had a really long tool and we want to get to a certain point in space and jog it around. It's a lot more user-friendly if we can tell through the software where the tool center point is. And in this case, this might be like a welding torch. So we could have a welding head on the robot, and we want to get that point right to a certain position in space. It could be a crimper. You know, it could be a whole bunch of suction cups that are picking something up. All of this is your end of arm tooling. And again, it can vary greatly depending on the application. It could be, you know, a series of different grippers. So in our application, we have a gripper that's set up over here, just a little pneumatic gripper. And as we're jogging it around in world mode with this tool frame set up, we can have that rotate about that axis, and it makes it really slick. So to demonstrate some of these things, how we would set up a new tool frame, first thing we're going to do is create a new tool frame. So I'm going to use some of these that I've created that we can put into the gripper and clamp onto it, and then this becomes our new tool frame, tool center point. So we'll demonstrate how this is done. So first thing we got to do is get it to open and close the grippers on the robot. So to do that, we're going to go into the menu button. So I'm going to press the menu here, and what we want to do is find the I/O, robot I/O. So I'm going to hit number 5, and oh, that didn't quite work. I guess I got to use the arrow keys to find input, output, and the type that I'm looking for is robot. So I'm just using some up, down, left, right arrow keys to get there, and there's the robot I/O. And this is how we can run the gripper on and off. So there we go. By pressing the soft keys, the on off, or I can press them on the touch screen as well, I'm able to get the gripper to open and close. So there we go. So what I'm going to be doing is to install this tool. I'll just kind of scoot this out of the way for a second. Into the end of the arm, and then turn it on. There we go. So now we have a longer, simulated a longer tool bit, in this case for the robot. Okay, so if I were to jog the robot around in world mode, so back to the teach pendant for a moment here. Just dead man switch shift reset to clear out any faults that are in the program. All right, so we're ready to go. And then as I'm jogging this around, I'm going to bring my z-axis up. And at this point, it's better just to look at this screen. We'll bring our z-axis up, and I'm going to put that other reference point back in place so you guys can see without this tool frame setup where we're at. So bring our Z down, and our Y, that looks pretty decent, and X minus, and bring our Z down. Trying to get these 2 points to pretty much touch in space. Okay, So that looks pretty good for this particular setup. Now I'm going to rotate the minor axes of the robot. So jogging in world mode still, and watch what happens when I'm jogging in world mode and I don't have my tool center point configured based on the actual length of tool. As I rotate these back and forth, it's not rotating about that tool endpoint. So I have to correct that. And how I can do that is to create a new tool. So to do that, we're going to create a new user tool frame, or new tool frame. So let's go into the teach pendant and see where those menus are at. So in the teach pendant, we want to go to the menu button. And then over here, what we're looking for is setup, number 6. So we just scroll down till we get to number 6. And that's where we can find the frames menu. Okay, so there's number 7 for frames, and we hit enter. And this is going to bring up, this says tool frames, setup frames, tool frames. So we're in good shape there. And you may not get to this screen by default. There may be other frames that are set up. So the type of frame that we're going to be working with is on the soft key here. And it is correct right now. Oops, I'm sorry. I guess it's other is what I'm looking for. Here's a few different frames. And primarily for us, we're going to be using the tool frame menu and user frames. And we're not going to spend any time on jog frames or cell floor. So we are in the correct menu for tool frames. Hit enter. And what I'm going to do is to configure tool frame number 10. And there's a number of ways we can do this. We can go into the detail for user frame number 10. And I can add comments in here to tell it what is it. So I could give it a name that says like long bolt or you know, long tool, something like that. But we can actually edit this. Let's see. You got to find the right menu. It's been a little while since I've done this, so that's okay. So comment, maybe I just hit enter. There we go. And then we can get into, over here we've got an option to bring up a keypad. So I'm going to bring up the keyboard, and I'm just going to call this long end of arm tooling. So I'm going to get this to be capitalized here. E-O-A-T. So long end of arm tooling, and then hit exit on this. And there it shows up as a name. So the comment here. And now we have options here about what method we're going to use to program this end of arm tooling. And I'm going to choose for this one a direct entry method. If we know what the length is relative to the end of the tool plate, we can set this up as direct entry, and sometimes you can just measure it and away we go. So let's take a look at the robot itself, and I'm going to zoom out a little bit. Wrong way. Okay. So by default, the end of arm tooling is the end of the tooling center plate. So here we've got a piece of aluminum that's been machined that the gripper is bolted onto in this case. And technically, by default, the end of arm tooling is right at that center point, right there, without us doing anything else. And I could actually demonstrate what that looks like. So let's go back to our teach pendant here for a moment. And I'm going to jog the robot using a different tool frame. And to do that, to change your tool frames in jog mode, we would hit the coordinate key, and the tool number here by default, in this case, is number 1. So I can change that to 10. Oops. So shift and coordinate, and It says point equals 10. So I want point. All right. There we go. So now the tool number is set to tool number 10, and you can see the parameters x, y, z for that tool center point are at all zeros. So now this should have its tool center point be right at the end of the arm tooling, the tooling plate, which is the black tooling plate located up here on the robot, and that's the 0, 0, 0 point for it. So if I were to jog this robot around now about the minor axes, you'd see that it changes the way it jogs completely. Okay? So now the tooling center point is actually inside the end of arm tooling. So that's considerably different. All right. So that's interesting for us to note. So let's go ahead and change our tooling so we get it set up for our long tool as we were planning to do. And to do that, we're going to need to take some measurements. So in this case, I've got a ruler that measures in millimeters. And if I go to the end of that tooling here, way down, it looks like I'm getting about 30 centimeters from this end of tool to the tip right here is 30 centimeters. So that would be the Z offset length in this case. So we're going to enter that 30 centimeters or 300 millimeters into the tool frame for number 10. So while I've got this set up here, we're at tool frame number 10 in that menu. And I can hit enter to go into the details here. And the method is set up for direct entry. And this is going to be simply a Z offset over here. So direct entry. And I said it was going to be 300 millimeters. Hit enter. There we go. And the configuration is all set up. So I think we're in good shape here. So let's see what that looks like. And go from there. I do want to back up here just a little bit. Yeah, so this is going to be, it makes sense that the one with the gripper was 220 millimeters from the center. And here we've added some length to it. So we've added about 80 centimeters to, or yeah, 80 millimeters to that length. So let's just verify that with the ruler over here that, yeah, from here to the end, yeah, that looks about right. That we're at 8 centimeters to that tip. So that should be in good shape. So now with that set up, we should be able to jog the robot around, and it should change that the way it jogs. So I'm going to once again get our XYZ set up so that those two tips, the tooling tip and then that fixed point in space for reference, are set up. And we can change the speed so that we can do this much slower. So bring our Z-axis down a little bit. X over. Sometimes I got to get a better vantage point of this. All right. So those two tips are pretty much touching one another. And now with the new tool frame set up the correct length, we can go ahead and rotate about the minor axes and see if it's doing its job. If we did it correctly, those two tips should pretty much stay together as it's rotating across here. And it looks pretty decent, actually. They're staying together for the most part. So it's kind of a magical deal that when you're jogging this robot and you've got your end of arm tooling set up correctly, those tool frames, it does some really neat things. So looks like it's not quite 100% where I'd like to be, but we do get the point here about how it's done. All right. So that's one method of entering a tool frame, is to do it through direct entry. So if you have you can take the measurements. If it's a simple offset from the end of the tool plate to the tip of your new tool, if straight Z, you can just enter that height. By far the simplest method. If you have a CAD model, you know the exact dimensions. It was drawn up in a CAD software, drafting software, and you know that the center point is at whatever location. You can use direct entry to put those numbers in, and it just makes it really simple. So those are probably the easiest ways of doing tool frames, is through measurements, or to have the dimensions of the from the tool center point to where it mounts to the end of the tooling plate of the robot. The other way to do it is to do it in space, and that's a little bit more interesting, I guess. They call it, they have a few different methods. I'm going to teach you guys the 3-point method. So if I want to figure out where the end of the arm is in space, I've got to figure out 3 points will define it in space. So what I can do is this 3-point method. You come down and program 1 point by having the 2 tips basically aligned and touching one another. Then we rotate the x-axis so that it's off to the side like this, and we come in and find it again and say bang, record that point in space. So now we've got 1 point and 2 points, and if we do it one more time by rotating it this way and coming in, finding the tip to tip point in space, and we record those 3 values, then it knows where that tool is in space. So to make this a little bit more interesting, I'm going to have it not just be a simple Z offset, but rather what happens if it's off to one side and we've got multiple dimensions that we're concerned about. So let's take a look at the robot and get that done. A 3-point method. So first thing I'm going to do is to remove this, and to do that, once again, I'm going to go back into the menu and find those input outputs, and I've got to be able to open and close the gripper. So it's a robot input output, and there's the one for the gripper. So I can just hit the on-off buttons to release that. There we go. So we're able to remove it from the robot, and now I'm going to put it in at an angle like this. Okay, so go ahead and put that in place, and our gripper is at kind of a funky angle, so it's not a simple Z offset in this case. The end of the arm tooling, do I want it there? I guess that'll be fine. Let me just rotate the put it in joint mode and just rotate that the axis number 6 so you guys can see where that tooling center point is. Okay, so there it sits at a funky angle. So not only are we offset in the Z direction, we are offset in an X or Y direction as well. And I'm not sure how exactly it's sitting on here, but may only be in one axis, but it's definitely offset. So we want that to be our new tooling center point. And let's go ahead and use the 3-point method to configure this. Okay, so we're going to use some joint jogging here. Yeah, this will be entertaining. So let's go ahead and move the robot around. I'm going to rotate joint number 4. All right, what I'm looking to do is get that so it's ready to go straight down and basically touch the robot, or that tip. There we go. Now I'm going to change the jogging back to world, and we'll go down with our Z. Let's see. Move over with the y-axis. I may be running out of physical room to do this. Yep, I hit one of the limits here. It basically limited out here. So I may have to rethink how I'm doing this. Or perhaps I can move this tool center point, this fixed point in space, over quite a bit so I have a better way of doing this. There we go. It's not so congested anymore. And we can still see that. Okay. So I'm trying to get these two aligned with one another. Okay, now we're getting somewhere with this. All right, so I'm going to adjust the camera so you guys can get a much better view of this, because we really want to see how those two are aligning with one another. There we go. And I'm just jogging it around so that those 2 points are pretty much fixed, almost touching one another. So I may have to decrease my jogging speed. And it looks like I can bring my z-axis down a bit. And what we're aiming to do is just get these two to pretty much be touching. Okay, I'm very happy with that. So I've got my first point of the 3-point method where these are basically touching one another, and we're going to go ahead and record that point. So on our teach pendant here, we have to go back into our teach menu where we're recording our frame. So that was setup. And frames is what we're looking for. Enter. And in this case, we're going to hit enter on tool frame number 10. And we're going to go ahead and change the method that we're using to program this using the 3-point method. All right. So we'll hit enter on this. And here's the approach point. Basically, we have to record 3 points in order to get this to know where it's at. So approach point number 1, and we can hit the record button here. You have to have the shift to hit record. So that is the very first point that we have set up, and that's basically with the tools touching one another straight on from the top. Okay. Now we're going to switch our axes and start jogging around to record our second point. So probably just going to change it to joint mode and move joint number 5. Let's see. Actually, I'm going to move joint number 6. Okay. So I've rotated this a few degrees, and it may be hard to tell, but that's good. Now we're going to go ahead and change it back to world mode and line up those 2 points again. So we're going to go X minus. Trying to get these 2 points to line up with one another again. Go down with my Z. And then just get real fussy about where this is. Okay, now we're going to change our jog speed way down and get those two so they're pretty much touching once again. So it looks like I need to go down on the Z-axis, a little bit of X positive, a little bit of Y negative, positive. Okay, so those 2 points are pretty much touching again. We got them lined up, so we just rotated one axis about, it was probably about 60 degrees. And now back to the teach pendant. We recorded 1 point with them touching pretty much tip to tip. Rotated and now we're going to record the second point. So shift and record for approach point number 2. It's recorded, and then we need to teach one more point. So back to the robot, we'll do some more jogging around, and let's see, we're going to jog it in joint mode for just a second here. Maybe not, maybe world mode for a little while. I'm going to bring my z-axis up so I got some room to play. Okay, now this is where it gets to be entertaining. I want to rotate a few axes so that this comes in from a different perspective and we can have that point down. So I think I'm going to rotate in joint mode this final axis. How can I do this? So I was here. This is going to require a bit of thought here. So, sorry about this. World frame. Okay, now I'm going to start moving some joints and getting this set up. So I'm going to move joint number 4. Try to get this kind of straightened out a bit. What I want to do is come at it from this side. So that's going to require some work to get my joints all figured out to make that happen. So this 3-point method can be a bit more time consuming, obviously. Okay, now we're going to rotate this axis about this way. There we go. Now I can come in and jog it in world mode and get that other axis lined up. So we're going to go Y positive, get these guys lined up. X positive, we're almost there now. And now I'm going to decrease my speed, so we're jogging at a very low percentage. And we're going to try to get these guys lined up perfectly. Okay, so that was a lot of finagling. But it looks like they're back and ready to go. So back to our teach pendant, and we've recorded our 2 points. Now we have one more point to go, and I can hit shift and record, and all of the points have been recorded, and it figured out a X, Y, and Z offsets by using that 3-point method. Now if we did this correctly, when we jog the robot around, that new tool point should be configured. So let's see if it is working properly. And to test it, all we have to do is rotate about the minor axes of the robot. So here's an X rotation. Look at that. Thing of beauty right there. Here's a Y rotation. And again, those 2 points are pretty much sticking to one another in space. And a Z-axis rotation. That is very, very cool to watch. So that's the 3-point method of programming in a new user tool. It basically, again, records the tool center point. So we'll have you guys practice those 2 different methods in the lab. You're going to be using both the direct entry method, and that's awesome for, especially if it's just a straight distance away from only the z-axis has changed. Then it's really easy. Just grab a ruler or a tape measure. How many millimeters is it from that end of the tool plate to the new tip? Put that in there as a direct entry method. The 3-point method we just showed you is a little more time consuming. But the idea, again, was that you're recording, you have a fixed point here, your robot comes down, you record this point, check. Then you rotate your tooling, come in and record this point. And then finally, you rotate your tooling this direction and come in and record your third point. And by doing that and recording those 3 points, the software calculates where is that end of arm tooling. And then it's really neat to use these tool frames to jog the robot around. It's a must-have for your programming. So that is tool frames, and it's going to take you guys some time in the lab to get both of those set up, but have fun with it, and we'll catch you next time.